All right, question 12, people, we're getting a gap fill. All right, come on, we can do this. GCSE level, we're definitely able to do this. This is obviously 0654 winter 2018 question paper 4.1, question 12, last one. We're talking about arrangements in in our solids, liquids and gases, or mainly just solid and liquid today. Okay, arrangement in particles in a solid is regular. It's a regular arrangement, means that it's a repeating pattern in comparison to our liquids, which are irregular. Okay, the forces in our particles in the solid are strong or close together. Okay, and in a solid, all of our particles are touching. Now, that's a bit of a weird way of putting it. Basically, what we mean is that every particle touches another particle. Okay. Going to B, this isn't actually on our syllabus, I'll talk about it anyway. Ice from the freezing compartment melts at 0 degrees. Explain in terms of molecules why energy is needed to melt the ice. Well, you should be familiar with the idea, even if you don't know what latent heat is. That's the bit that's been taken off the syllabus. Okay, so this bit here probably would be out of the answer for you guys, but you might be expected to explain why energy is required in order to cause a change in state. The idea being here that energy is required to pull my particles from this arrangement into this arrangement. Okay, we've got attractive forces pulling the things together, so in order to move those particles apart, I have to do work, I have to put in energy, and so therefore we need to separate those molecules using that energy. What we call this is the latent heat of fusion. As I've said, this is not on our syllabus, don't worry about it too much. It will come in handy in IB though. Okay, this is relevant to us. Question C, we're looking at a refrigerator with a freezing compartment at the top. Okay, describe how a freezing compartment enables all of the air to be cooled. This is a question about heat transfer, and remember we've got three types of heat transfer. We've got conduction, we've got convection, and we've got radiation. The reason I write that down is because if you're ever needing to think about how things heat up, it is always going to be because of one of those three, or maybe a combination of those. In this case, it is convection. We're looking at convection here. Okay, we're looking at convection. Why? Well, at the top, we've got something cold. And what we know is that when we cool something down, it sinks. Well, if something falls down, if the cool air falls down, then the hot air at the bottom moves up to replace it. And that's setting up something called a convection current. Okay, this up here is my convection current being set up by the freezer. So the way this works, the compartment cools the air at the top, the cool air moves down, and the warm air at the bottom rises or moves up, and this sets up a convection current, allowing me to continue to cool these things. It's just exactly the same as an air conditioner. The air conditioner cools everything here, that cold air falls down, and the warm air comes back up again. Last one, not on syllabus. There's an equation, E equals mc delta T. This was actually used in a recent paper 6 example. We had, instead of M, we had a volume. It's the same thing really. C, we had 4.2. That's really, that was the specific heat capacity of water. Okay. For those of you interested, the way that we calculate a temperature, an energy as a result of the temperature change, we use this thing, the specific heat capacity C, multiply it by the mass, and then multiply it by the temperature change from 20 to 5. So that's 15, and we get 3.8. As I've said, not in the syllabus, you don't need to worry about it.